Hello friends, welcome in the next lecture of Calculus First. Before this we discuss first chapter of Calculus First, that is the real number, and in the today's lecture we have to start our second chapter, that is sequence. So we start up our second chapter, sequence. The meaning of the sequence in mathematics is similar to the meaning in the ordinary English. That is, sequence of some events or sequence of some objects. We are saying that this is first object, this is second object, this is third object, and so on. Or we can say that this is first event, second event, third event, and so on. That means, suppose we have any set and we are giving this is first object, this is second object, or this is the first element, second element of the set, then there will be a sequence of numbers in the sets. In the Calculus First, we have to discuss the sequence in a real number set R. That is, we have to define only the sequences in the set of real numbers. So we start our topic, that is definition and examples of sequences of real number. That is, we have to discuss sequences in a set of R only. Okay. So first we write the definition. So simply definition, we can say that sequence is just a function. Sequence is just a function from natural number to the R. This is the very simple definition. That is, if x is any function then which is from natural number to the R, so this is our sequence. That is, the elements of R, we are giving number to these elements is 1, 2, 3, 4, 5, 6, and we get one function, and this function is nothing but our sequence. So we write that first definition, the sequence in R, or we can write this of the sequence of real numbers. So what is it? The sequence in R is a function from n to the R whose range is contained in the set of real number, that is R. That is, sequence is just a function. It is just a function from n to R and whose range is contained in a set R. Okay. So in other way we can write the definition. In other words, so what we can see, sequence is just a function. So you know the definition of function. Function is a rule that assigns every element of a domain to the unique element of a codomain. In the similar manner, here we can write, here our codomain is what? Here domain is what? N, and codomain is what? R. So sequence is again a function whose domain is N and codomain is R. That is, every element of N, that is the natural number, assigned to a unique number in R. That is, we can write it is in the other words, that is a sequence in R assigns a natural number n is equal to 1, 2, 3 and so on to a uniquely determined real numbers. Or you can write the definition similar to function also. Okay, so what you are getting, sequence is just a function. Suppose we have any x is a function, or we can say that x is a sequence, and it is a function from n to the what? R. So what we can say that this is our sequence x from n to the R. In the terms of function, what is this x of n? What it denote for function? What it denote? It is value of x at n. Is it? But in sequence, we rather than x of n, we write xn. And what is xn? Xn is the nth term. So here we say xn is nth term or element of the sequence. So what is the notation, or how we denote the sequence? X from n to the R is denoted as by x. It is denoted by x. Simply x you can write, or you can write xn in parenthesis. That means it is in the open bracket, or you can write xn where n belongs to the natural numbers. N belongs to the natural number. So this is the simple notation of the sequence. Here what we can say, note. We can write the note. What this parenthesis? Shows that ordering induced by the natural numbers. That means what? This is not a single term. That is, here is a sequence, and here is all the terms are in the sequence of, or they are ordered terms, we can write. Then what we can say, in second note we can write, that means what? This xn, n belongs to the natural number. What it denote? It contain infinitely many terms. It contains infinitely many terms, and what we can say, they are ordered. Terms are in order. That is, this is not denoting the set. What it denote? It is sequence xn. that contains infinitely many terms, and these terms are ordered terms. Is it? But if we have, this is like this, all xn, n belongs to the natural number. N belongs to the natural number. What is it? What it denote? This denote our the range set. What it contain? Which contain ordered or not ordered. Finite or infinite number of terms. Okay. Okay. What it means, the difference between these two, this is the sequence, it contains infinitely many terms. These terms are ordered by a natural number, like first term, second term, third term. But this is just a range set. This range set denote the range set. This denote the range set, and it contain order or non-order, finite or infinite terms. For example, if you are taken the sequence -1 raised to n, all n belongs to the natural number. All n belongs to the natural number. And what it equal? This is nothing but our what? This is just a sequence. N is equal to 1, this should be -1. N is equal to 2, this should be +1. That means what? It is the sequence of alternate numbers -1 and 1. That is -1, 1, -1, 1 and dot dot. That means this contain infinitely many terms, alternate terms, that is 1 and -1. And this set, and now we have -1 raised to n, n belongs to the natural number, and this is nothing but our the set 1 and -1 only. That means this contain finitely many terms. Is it? They are ordered or not ordered, we can say. That means these two are very different things. So keep in mind, it is very important. This parenthesis denote the sequence. Okay? Sequences can be defined by giving some nth formula. That means suppose we have given the sequence, suppose x is equal to minus or 1 upon 2 raised to n. So this is the nth formula for the sequence. So how we write this sequence? This sequence can be written also like this: 2 raised to n, all n belongs to the natural number. And what is it? This is nothing but 1 upon 2 raised to 1 is 2, 1 upon 2 raised to 2 is 4, 1 upon 2 raised to 3 is 8, 1 upon 2 raised to 4 is 1 upon 16, and so on. That means every sequence is given in terms of a nth formula. Okay? So there is another way of defining the sequences. There is another way of defining a sequence which specify the value of x1 and write a formula for xn plus 1, all n must be greater than or equal to 1 in terms of xn. And this type of sequence is called inductively, or we can say recursively defined sequence. That means what? What it means, there is another way of defining a sequence. What it specify? It specify a sequence, that is the first term. It specify a first term, and then we are writing the formula for xn plus 1. We are writing the formula for xn plus 1 in terms of xn. In terms of xn. For example, we are taking, suppose x1 is equal to 2 and xn plus 1, we can write it is in xn plus x1. xn plus x1 for all n should be greater than or equal to 1. It should be greater than or equal to 1. Okay, so you can get the next terms. So how we find n2, x2? How we find x2? x2 should be what? N is 1, so x2 is equal to what? x1 plus x1. It should be what? 4. Then what we can get? x3 is equal to what? x2 plus x1, and it can be that is 4 plus 2, you are getting 6, and so on. That means what? This sequence xn plus 1 or nth formula we are written, it is in the formula of xn and x1. xn and x1, or you can write it is in terms of x1. Okay, so now we write some examples of the sequence. Of real numbers. Okay. So first example, let B belongs to the R and the sequence B, if you are taking all B, that is the whose all terms equal to terms equal to B is called a constant sequence. Constant sequence B. For example, constant sequence 1 is what? Constant sequence 1 is what? It is 1, 1, 1 and dot dot. Similarly, we can write constant sequence 0 is, it should be 0, 0, 0 and so on. That means the first, that is the sequence whose all terms are equal to B. This type of sequence is called as sequence of a sequence is called constant sequence, and it is of course sequence of a real numbers. And for example, constant sequence 1, we can write this is 1, 1, and dot dot infinite times. Similarly 0, similarly you can write any number. Constant sequence means all terms are equal. Next example we have to take. Second example, if B belongs to the R and suppose we have a sequence B is equal to, it is equal to what? B raised to n is a sequence of real numbers. B is equal to B raised to 1, B raised to 2, B raised to 3. Just put the values n is equal to 1, 2, 3, 4, 5 and so on. That is b raised to n is a sequence just like this. For example, or in particular, if b is equal to, we are taking 1 upon 2, then what we are getting, then b is equal to 1 upon 2 raised to 1, 1 upon 2 raised to 2, 1 upon 2 raised to 3 and so on. This is just a sequence we are getting. Okay, in the similar manner you can take any particular case. Third example. Suppose we have a sequence of even number. The sequence of even natural number is 2n, all n belongs to the natural number, can be written also in the form what we can write this sequence of, this is the sequence of a even natural number, and we can write it is in the form of, suppose x1 is our 2, and we can write xn it is equal to, or xn plus 1 it is equal to xn plus x1 for n is greater than or equal to 1. We can write y1 is equal to 2, yn plus 1 it is equal to yn plus 2. Here also n should be greater than or equal to 1. Okay, so sequence of even number. Similarly, we can write the sequence of odd numbers. How we write this? This is nothing but our 2n minus 1, where n belongs to the natural number. Okay, the celebrated F.Y.B.Sc sequence is equal to fn, f is equal to fn, where f1 is equal to 1, f2 it is equal to 1, and fn plus 1 it is equal to fn minus 1 plus fn for n must be greater than or equal to 2. This is called as the Fibonacci sequence. In this sequence we are getting the number, the next number is just the addition of immediate preceding two numbers, or sum of the two preceders, immediate preceders. Is it? That is the Fibonacci sequence. That is the sum terms of Fibonacci sequence. It can be written as, that means some terms we can write, first term is 1, second term is 1, then 1 plus 1 is 2, 1, 2 plus 1 is 3, 2 plus 3 plus 2 is what? 5, and 5 plus 3 is 8. You can write so many terms. 8 plus 5 plus 8 is 13, 13 plus 8 is 21, 21 plus 13 you can write it should be 34, and so on. That means you can write the some terms of the Fibonacci sequences also. That means what we can say, that there are so many examples of these sequences. So today we discussed the definition and some example of the sequences. So thank you very much.